Okay, doing homework 2-2. So it's a continuation about correlation. So let the predictor variable x represent height of male, and let response, which means x, predictor is x and response is y, represent the weight of male. So the height of male and versus weight of male. A sample of 156 heights and weight result in S that is equal 16.35594 centimeters. In your own words, describe what the value of S, E represent. Okay. The value of S is a standard error, first of all. That's why we have E. Standard, S is a standard, E is an error. And it's a standard error of the estimate. Okay? And that standard error measures the difference between observed weight and the weight that is predicted. Remember, we were doing Y minus, let me see, y minus y hat, where y hat was predicted and y is our observed value. So in this case, we have the value standard error of the estimate is measuring the difference between observed weight and the weight predicted for the regression equation. Let's see, which one is it? Is there a difference between observed weight and weight predicted? This one. The first one or second one? Let me see which one it is so I won't make mistake. The value is the standard deviation of, of estimate. No anything else. Yeah, it's a standard error of estimate, which is a measure of difference between observed weight and weight of a predicted value from the regression equation. Yes. All right. Next question. What do we have? Let the predictor variable x represent height of male and response variable represent weight of male. A sample of 153 height and weight result in standard error 16 point blah 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 centimeters. Using the regression found from the data, a height of 175 centimeters is used to find the predicted height 91.3 kilo. Okay, and the 95% prediction interval is 59 and 123. Okay, write a statement that interprets that prediction interval. What is the major advantage? Okay, let's go step by step. So, what do we have? We have 175 height is used to find the predicted weight 91.3 and the 95% prediction interval is 59 and 123.6. Okay. So, what is going to be our answer? That we are going to say we have 95% confidence that the limit of where is it of 59 kilo and 123.6 kilo contain the value of the weight for the male with the height of 175 centimeters. Contain the mean of all male. Okay. value of weight for all main. So it should be this B. Let's check. Why? It should be it. So 95% confidence that the limit of 59 and 123.6 contains the value of the weight, okay, for a male with the height, okay, this one, with the height of 175, okay, this should be it, okay. Next one, what is the major advantage of using a prediction interval instead of simply using predicted weight of 91.3 kilos? Okay, so let's see, the advantage of prediction interval is that it gives a range of likely weight instead of a single value, but not as large of a range as confidence. That's not it. The advantage of, because not as large of a range as confidence interval. Okay, no, let me see. The advantage of using prediction interval is that it gives range of likely let me see. Likely weight. So we have a sense of how accurate, yeah, it would be this one that will fit. Prediction interval is that it gives a range of likely weights, okay, it gives likely weights. The first one I chose is also so far so good. Then continuation for the A was instead of single value, and here it says of likely weight, so we have a sense of how accurate the predicted weight is likely to be. Okay, which means it's falling, we are going to know in what range, with how many confidence interval it's gonna fall the predicted weight. Well done. Okay, so if we say there is no advantage to use, that would be wrong. And if I would choose the advantage of using prediction interval B, I'm reading B, is that gives a range of weight that contain a true value as opposed to the predicted weight, which is an estimate. That is not true. That is absolutely not true. It doesn't give you the predicted estimate. It's give you accurate. But to say that the prediction is more accurate, but not as large of range as question A reading, but not as large of a range as confidence interval, that's no. So C is the answer. Okay. Next, why is the terminology of prediction interval used instead of confidence interval? Well, because prediction interval is used for an interval that estimate of variable, and confidence interval is used to it's an interval that estimate the population parameter. Okay, here we are estimating the variable that we don't know. Okay, for interval is population parameter. No, variable, this one. Let me read. A prediction interval is used for an interval estimate of variable, whereas confidence interval is used for interval estimate of population parameter. Yes. So prediction is predicted the variable, what is going to happen. while the confidence interval, it's finding the population parameter, which it can be proportion, can be standard deviation, variance, or mean. Okay, so we are done. Okay, we are moving to question number 3. Assume that you have paired values consisting of heights in inches and weights in pounds from 40 randomly selected men. The linear correlation coefficient R is 0.447. Okay, correlation coefficient. Find the value of the coefficient of determination. Okay, to find the value for the coefficient of determination is we take R and squaring. R squared, that's going to be your coefficient determination. So my R is 0.447 and I'm squaring 0. 0. It's going to be the numbers, it's going to be 200. I guess 20%, yes. 0, oh, here it is, 0200, so it's going to be either B or D. So 0.447 squared is 0.200. Okay, so what's the practical information does the coefficient of determination provide? So what is the determination, coefficient determination? We learned that coefficient determination is a correlation coefficient squared. So now what does it do? What information does it carry? So the coefficient of determination is 0.200, right? Which is 20% of the variation is explained by the linear correlation, and 80% is explained by the other factors. I'm going to cover this in lecture. I'm just writing this down so you would these problems, and then I'll go back to lecture, continue all this, and you will understand. So the coefficient of determination is a ratio between explained variation wait a minute, no, I chose wrong one, this one, between explained variable and explained by others to total, which is, it's going to be 80% from total. Okay, let's check. Well done. Next question. What do we have in this case? So we need to find coefficient of determination that we already know what to do. So 0.617, we are squaring and getting around till 4 decimals. So it's going to be 0.3807. Okay, very good. So explained variation, then explained variation is going to be, so it's 0.3802, that's going to be 38.07% because it's a percentage. So 38.07, look at the coefficient of determination, 0.3807 as a percentage, it's going to be explained variation 38.07%. Okay, moving to next question. What do we have here? So we need to find prediction interval, okay? I guess we are going to StatCrunch, huh? So we choose StatCrunch. This is what we're gonna do, choosing stat, regression, simple linear, and we are choosing our x, we are choosing our y. Next, we need to know, because we are doing predicted value, so we need to know how many percent. 99% confidence level I have, and my x is right here. X is 84 and confidence 99. So because we are going to predict, right, the y for our 84. So what am I going to do? I'm choosing confidence. I'm typing is 99. Okay. X, I'm typing 84. Right? It was 84. Yeah, 84. Okay. And level also 99. Okay. We have it. So let's click compute. And here it is, our predicted value. So we have 99 predicted interval for new. It's going to be 37.28. Let me write down 37.28. 37.28 and 101.17. Okay. So let's write down. It's going to be 37.28 and 101.17. Okay. What is wrong? Let's double check again. Let's go double check again. 3 decimals. Duh. Gee, I have to go through everything again. So it's going to be stat, regression, simple linear, this, confidence, we have to be 99, and this is 84 value of x. We're just plugging into equation. This is also 99, and we go to compute. So 37, okay, 290, then it's going to be, if I round it, 290, and 101 is going to be 168. Okay, 168. Moving to do our homework, it's going to be 37.2, where is it, 90, and moving here, it's gonna be 168. Okay, we got it. Question number 6. So we are going to find explained variation in this case. So we choose StatCrunch. This is what we're gonna do, choosing stat, regression, simple linear, and we are choosing our x, we are choosing our y. Next, we need to know, because we are doing predicted value, so we need to know how many percent. 99% confidence level I have, and my X is right here. X is 84 and confidence 99. So because we are going to predict, right? The Y for our 84. So what am I going to do? I'm choosing confidence. I'm typing is 99. Okay. X I'm typing 84. Right? It was 84. Yeah, 84. Okay, and level also 99. Okay, we have it. So let's click compute. And here it is, our predicted value. So we have 99 predicted interval for new. It's going to be 37.28. Let me write down 37.28. 37.28 and 101.17. Okay. So let's write down. It's going to be 37.28 and 101.17. Okay. What is wrong? Let's double check again. Let's go double check again. Ah, 3 decimals. Duh. Gee, I have to go through everything again. So it's going to be stat, regression, simple linear, this, confidence, we have to be 99. And this is 84 value of X, which is plugging into equation. This is also 99. And we go to compute. So 37, okay, 290, then it's going to be, if I round it, 290, and 101 is going to be 168. Okay, 168. Moving to do our homework, it's going to be 37.2, where is it? 90, and moving here, it's gonna be 168. Okay, we got it. Question number 6. So we are going to find explained variation in this case. So we are going to StatCrunch. Stat, regression, simple linear. Fill out this, and getting compute. So when we get compute, our explained variation is under SS, sum of squared, sum of residuals. Remember, we were saying that sum of if we can minimize sum of residuals, then the model will fit the best. So SS, sum of residuals for the model 1 is 101.78. Let me write down 101.78 8 point, there are two decimals, I believe, 0.83. Okay, and unexplained one is gonna be 158, 158.0203. Okay, so let's go back and place it. So explained, it's gonna be explained variation 161, 61 point, no, 16178.83. Did I write down wrong? Where from I got this? Oh, I put wrong one. 10178.83. Let me write down this step by step. One zero one 78.83. Okay. Next is going to be unexplained variation. Let's go back. Unexplained is going to be error. So that is error under sum of squared. That is going to be 158.03. I have it here written down. 158.03. Okay, so what else we have left? Prediction interval. So for prediction interval, how much is our probability, interval of confidence? 95%. And how much is the value we want to figure out? 6.327. 6.327 thousand, so 6,327. Okay, 6,327. All right, let's plug it back. We need to change this, so not to start over everything, I'm clicking option, edit, and I'm going to confidence interval. I have 95. Whoever doesn't have 95, change where level is and change here under prediction. So X value is 6.327. Okay, and let's go compute. And here it is, predicted values. So it's going to be how much? 2524. Oh, 4 decimals. So it's going to be 252459. 25.2459. And for the other one, upper limit, we are going to have 58.5927. 58.59, 58.5927. Okay, we are done. So question number 7. Question number 7, it's going to be exactly same thing, so you can do it. I'm not going to do it. See if it will open. No, it won't open. So question number 8. Let's see what we have here. Okay, this is different story. So let's understand what we have. It's going to be what deviation xy is a vertical distance between y minus average. That is going to be our total deviation. Total deviation of xy is a vertical distance of y minus y bar. We are trying to figure out how far it is drifted. Deviation, nothing else but error. So we want to find out how far observed value drifted from the average one. That's a standard deviation, which is the distance between point xy and the horizontal line passing through sample mean. Okay. Question number 9. Okay, what do we have here? The coefficient of determination r squared is amount of variation in y that is explained by regression line. So coefficient determination belongs to y, is the amount of variation in y, and that's explained by the regression line. Question number 10. Okay, what do we have here? So, is an interval estimate for a predicted value of y. Okay, what interval is that? Confidence interval doesn't estimate predicted value. It estimate the mu parameters of the population. It's not residual. It's prediction interval. It's predicted. Question number 11. So, what do we have here? Is a measure of the difference between observed sample y value and predicted value that we call standard error of estimate. So the difference between observed and predicted. Okay, that is our standard error of estimate. Question number 12. So, what do we have here? Deviation is the vertical, between predicted and average. That is going to be our explained. Explained deviation is the vertical distance between predicted y bar and and y head and y bar. Got confused. Y bar is our average, y head is our predicted value, which is distance between predicted value passing through the sample mean. That's exactly what it is. And we have the last question. Those are simple questions, but very important way to understand what is what, to learn it. So the last one, deviation. Oh, that's the same question, isn't it? Yeah, it's the same question. Well, take a guess then. I'm not answering. That is the same question. Okay. Moving, and I think we are done. Yeah, we are done. Okie dokie.